Thank you for the introduction. Good afternoon, ladies and gentlemen. I am here to share basically our experience in waste to energy concept, and to be specific, how biogas can be converted into power, or biogas can be converted into a compressed natural gas or compressed biogas. So we are going to see and learn about the project which we have executed and which is running in India. So I would like to first thank you IGEM to giving us the opportunity to present our case study here. We are a company of 70 employees from India. It's a Pune based company, and we do EPC turnkey projects for biogas based plants. The photograph what you are seeing, these two photographs are of the actual plant. On the right hand side what you are seeing is the scrubber, which basically removes the hydrogen sulfide from the biogas. We will discuss about it in detail. And the left hand side, this photograph, these two are the CO2 removal columns, and the shade what you are seeing is the compressor, which compresses the gas into up to 200 bar. Now always the question comes, who are we? So we are basically biogas cleaning and upgrading technology provider, and we provide EPC turnkey solutions for Bio CNG and biopower. My name is Ashish Nawade. I have done MBA from London Business School, and I have 25 years of international EPC experience. I worked in Japan, UAE and UK, Italy. Then returned to India last year basically to pursue the renewable energy sector. As a company, this company is 20-year-old, and we have been working in the areas of renewable energy. We are the only company in India who had commissioned successfully and operating a 9 tons per day plant for one of our customer for Bio CNG. The first large-scale biopower plant in India also was executed by our company. As of today, 65 megawatt of power equivalent renewable energy power our company has helped our customers to generate, and we have completed successfully 33 plus projects. We have 4 projects in running now. We have a strength of 70 employees. How do we do this? It's not a rocket science. Biogas to power has been in use for long, and biogas contains methane up to 55 to 60%, sometimes 65% based on the organic waste what you receive. It also has carbon dioxide 30 to 35%, and rest up to 5% sometimes is hydrogen sulfide. Hydrogen sulfide concentration varies based on the application. If it is sewage, the hydrogen sulfide is less than 1%. If it is a distillery sugarcane waste, it is up to 3 and 3.5%. And if it is municipal solid waste, it is also up to 1 or 2% based on the technology what is used. So we have our own technology for hydrogen sulfide removal. When we have to produce power from biogas, we only have to remove the hydrogen sulfide because it's a corrosive and poisonous gas. It can corrode our equipments or the engines, and the life of the engine comes down because of the oil changeover required and the metallurgy required. So it is mandatory also from the environmental regulation point of view that we cannot burn hydrogen sulfide and form SO2 and send it to environment. When you have to make Bio CNG, any feedstock we can generate a biogas. Once the biogas is generated, we remove hydrogen sulfide through our bio scrubber process, remove CO2 through our CO2 scrubbing process, which is a pressurized water scrubbing. Then we have to dehydrate the gas and compress it to 200 bar to bottle it, which is a CNG basically. So this we put it in a cascade, and presently we have replaced industrial LPG with Bio CNG in India, in one of the district of India. Biopower, we have done many projects, 33 projects, and the route is very simple: biogas generation, hydrogen sulfide removal, and power generation. So it's the simplest route. As a company, we offer renewable energy engineering services and oil and gas. I will focus on renewable energy now. So we are also into municipal solid waste treatment and biogas and biogas based power plant and Bio CNG. Municipal solid waste, if you see, it requires pre-treatment because it is not segregated most of the time. It's not like Europe where we have organic segregated at home. So we offer a complete package where if municipal solid waste is available to us, we pre-treat the municipal solid waste through anaerobic digestion route. We produce biogas and then again go for a biopower or Bio CNG route. The leftover or the discarded material is incinerated or sent to landfill. When we do incineration, we produce power, and the digested what has come out of the anaerobic digestion is compost is done and organic fertilizer is produced, which will help the farmers to grow organic crops, hence adding the value. This is a typical flow diagram of if any municipal solid waste treatment plant is there, from where through anaerobic digestion route if you have to produce biogas, how it will come. So if you see here, on a receipt of municipal solid waste, we have basically a pre-treatment facility which is nothing but the shredding. There are sieves, there are magnets to take out the metals and also discard the dead animals what we receive from here. And the rejected material, which is more than 100 mm, goes to the landfill. The next is the digester, which basically a dry fermenter which will ferment this organic waste and convert it into a gas. And the route which is next is what is a common route, which is basically remove hydrogen sulfide, produce biopower, remove the moisture content, remove the CO2 and produce Bio CNG. And the last one is the organic fertilizer. So this is a typical process flow diagram which will follow in case of any opportunity in municipal solid waste in Malaysia. Now these are the various feedstocks, what we can use basically. Here definitely municipal solid waste, agriculture waste, animal waste. We are also working on a cow dung based project where from cow dung we can produce the CNG in a smaller capacity, which is a scaled down model of what we have done for 9 tons per day. Industrial waste basically could be from distillery, palm oil companies. We understand there is a huge scope, that's why we are here basically to explore the possibility of using this effluent from palm oil and produce biogas and convert it into either power, because you have plenty of gas available in Malaysia, so you may not need the CNG. Sewage treatment plant, the biological sludge which is coming out of the sewage treatment plant is used to generate the biogas and followed by biopower. There are beneficiaries which we know: farmers, gas producers, industries and the nations. Now why are we here basically? So first of all, we are receiving a lot of inquiries from Malaysia and Far East, and we understand that there are close to more than 400 palm oil mills. I may be wrong here, please correct me. There are large volumes of municipal solid waste project which are going to come. They are in the pipeline. The government has taken initiative for green revolution or green energy production. Sludge from the sewage waste presently is not efficiently handled, so there is not enough biogas generation in the sewage treatment plant. So we see there is an opportunity for people like us who can help with their experience in India and Philippines to generate more biogas and have biogas based power plant or CNG plant. Now when we are looking at the process, the hydrogen sulfide removal process is the key. So we, as I told you, we have our own technology. We call it as a bio scrubber. So this is basically a biochemical scrubber which can scrub hydrogen sulfide from ppm level to percentage, up to 10% of H2S we can remove. And our core strength is bio scrubber because We use caustic for our scrubbing. We regenerate the caustic by use of our nutrient and biological sludge, which helps us to reduce the operating cost. So if you see the equation, we have hydrogen sulfide and the caustic equation is there. Sulfate is formed and the water is formed. We add half oxygen in our reactor and liberate the sulfur. Now this sulfur which is liberated is used as a fertilizer. We have done research with the Agriculture University in Maharashtra state of India, and they did a 6 months trial on various soils and under various conditions, and they came back with the result that it will improve the yield of sugarcane crops, oilseed crops, onion by 15% or vegetables. So we are already selling this under the brand name of Sulfa-backed in the state of Maharashtra. There are 2 districts we are selling 300 ton per year we have sold as a fertilizer directly to the farmer. And I am very happy to share with you that we received the grant very recently from the National Agriculture and Agriculture Bank for Rural Development in India, NABARD, to develop this program further and to work in association with the Farmers Club of India, so that this sulfur can reach the farmers and the yield of the crops can be improved. So this is our key process here. We can offer this process independent whether we do a plant here or any one of you require hydrogen sulfide removal system. We can offer it for biogas, we can offer it for natural gas. Then the CO2 scrubbing, what we have seen when we have to make Bio CNG, we also require to remove the CO2. So we use pressurized water scrubbing, which is basically a robust, reliable and functional system. It's a proven technology, and we have added now in our process the reflux system to reduce the loss of methane. See, ultimately the biogas, which had a 55 to 60% of methane, we were enriching it by removing hydrogen sulfide 5%, by removing carbon dioxide 32-33%, and enriching the biogas to biomethane up to 95 to 98%. So by this process, this methane which brings the higher calorific value or comparable to the LPG, can use as a replacement to LPG, industrial grade LPG. So this is about the project which we are going to discuss. It's a Bio CNG project we have done for a company called Spectrum Renewable Energy at Varna in Maharashtra. We have provided the complete biogas upgradation plant, and we have brought down the the parameters, like we have improved the methane up to 95%, H2S less than 5 ppm, and dew point of the CNG or biomethane was minus 40 degrees centigrade. We have done testing at ONGC lab and we got the similar kind of results. So this is the process flow diagram for the Bio CNG. So this is the anaerobic digester. We receive here press mud from the sugarcane waste. The sugarcane factory, sugar factory with a distillery. So the press mud is fed here in the anaerobic digester, and it produces biogas. And the biogas whatever is produced contains hydrogen sulfide, so it is fed to the scrubber, which is our bio scrubber. The gas comes from the bottom and the caustic comes from the top. We have multi nozzles here, and this is the packing. So there is a counter current, and then the rich caustic with H2S goes to the bioreactor. In this bioreactor we add our nutrient and we have sludge. So there is that's why its process is called as biochemical, because we are using chemical here. Here is the biological process. Now the bacteria in this reactor, they help to liberate the sulfur. For that we add half oxygen here, which we have seen in the previous equation. So this is the first reaction which happens in the scrubber, and this is the second reaction which happens in the reactor. So this is the first reaction here, chemical reaction, and second is the biological. So we liberate the sulfur, and sulfur root, this is the sulfur root, which goes for drying, and the sulfur can be formulated and sold to the farmers. We use centrifuge now basically for solid liquid separation. Now the treated gas, which we bring down here from 3.5%, which is 35,000 ppm to 200 ppm of H2S. Then we use catalyst to bring down from 200 ppm to 5 ppm, because the quality of gas which we are supposed to sell requires less than 5 ppm of H2S. The gas, this is the gas holder which requires for volume collection. Then we have an intermediate compressor which takes the pressure of the biogas up to 7 bar, and then we have the CO2 scrubbing system here, where we remove CO2 32% and then dehydrate the gas, and this is the main compressor which is compressing this gas biomethane up to 200 bar, and then we have a cascade system here. So where it is loaded on the trucks basically to deliver to the industry. When it goes to the industry, the cascade, again you require a pressure reducing station, because from 200 bar again you have to bring it down to less than 1 bar. So this is the whole value chain actually. If you see the figures, there is 100 tons per day of press mud is being fed. We do receive distillery gas around 14,000. We have a yield of 80 cubic meter per ton of press mud. So we receive 22,000 cubic meter per day of biogas. We produce 9 ton per day of Bio CNG. This plant is designed for 9 ton. Today it produced 7. Yesterday it produced 7.7. So we have a tracking system where we get reporting every day, and it also generates power for self consumption, captive consumption. So we are not drawing any power from the grid. So it's a self sufficient plant. These are the parameters which we discussed. So 20 which we have seen, the dew point and the carbon dioxide. Now this is what is the actual site. These are the actual site photographs. This is a press mud which is stored in bays, and this is a material handling system which brings the press mud to the feed tank. These are the digester, 22 meter diameter, 7.5 meter tall, and 3 numbers. So to produce the biogas. So we are feeding 100 tons per day here. This is the bio scrubber or the power generation, So here, what we have seen in the drawing, process flow diagram, you see the yellow line, which is basically a biogas line coming from the digester. This is the scrubber where the chemical equation, caustic wash take place. The caustic comes from this stainless steel line you can see here. The caustic is sprayed over from here, and this is a treated gas line which is going to the catalyst vessel. This is a gas holder. This is the reactor in which the biological action takes place. The bacteria basically liberate the sulfur from here. This is the photograph where you have this shade where the intermediate compressor is there. These are the 2 CO2 removal absorber, desorber. Then we have a dehydration system here, and this main shade is basically for the compressor which is supplied by Bruchard, Switzerland, for 200, taking it to 200 bar. And you cannot see here, but there are trucks lined up here daily basically to take away the CNG. Generally we discuss this, that it is basically a clean biotechnology. The important thing here I would like to share is, in our process, our technology, we don't make sulfur in the column. Unlike our other technology available in the market, they make the sulfur or sulfuric acid in this column or reactor, whatever they call. And what happens if the percentage of H2S or the ppm level increases, they have clogging in the reactor or clogging in the column. And that's why they require to wash the column every month. What we are doing is, we are only scrubbing in the column, and we are producing the sulfur in the reactor which is outside the system, which is not in the gas system now. So gas to liquid scrubbing was done here, and the sulfur was produced here. So we don't have any issue, a clogging issue basically. So our plant runs for continuously for 11 months or 10 months, and whenever you get a shutdown of the generator or the compressor, we go for a shutdown. So this is the beauty of our process. And we are able to generate 90% of the caustic. So we Whatever caustic was used, we require 10% makeup. So that brings down the operating cost of our plant lower. So we offer low OPEX. So why we should go for Bio CNG? Like basically, if you see, we are improving the calorific value. It's a replacement for industrial LPG, or the addition to the fossil replacement. Reduction in carbon footprint. It's a clean CDM. CO2 emission reduction, and can be fed into the gas network, provided it is allowed by the regulatory authority. These are various 33 projects which I was talking to you we have done in India, and one project we have done in Philippines for a distillery for biogas, again cleaning. So you can see we have got presence all over India. This VA Tech, if you see, this project is for a sewage treatment plant. We are producing 2 megawatt. The project here, Pioneer, is a distillery. We are producing 5 megawatt. And then rest you are varying. This project Sanjeevani 2 megawatt is this biogas power plant is co-owned by us. So we also operate. We operate 10 plants in India for our customers, and this is our own plant Sanjeevani, where we receive the gas from distillery. We treat it and we produce power using GE and Barker engine. So these are our key clients. Kanoria Chemical was the first client with whom we started in 1998, the biopower plant. Petrofac, people from natural gas industry, they know, is the largest EPC service provider in Middle East. We are doing some engineering services job to them. Dhampur Sugar is one of the largest distillery in Uttar Pradesh in India. We have recently we have got an award from them, and we will be completing that project in the month of December. Indian Glycol, they produce green ethyl glycol, MEG, from biogas. So they are using our technology for hydrogen sulfide removal up to 0.1 ppm. This is Radico Khitan. So these are our client list: Spectrum, Green Elephant, Praj Industries, United Spirits. So these are the details, various basically, that what capacity and what H2S percentage we have done. So I will not go through this, and I would like to thank everyone for listening and giving me opportunity and listening to me. So if you have any questions.
Yep, any questions? You can raise your hand right now. I will pass the mic over to you. We still have a queue. Yeah.
Syngas is a produced gas. Basically, it also contains hydrogen sulfide. We can treat syngas. We can treat landfill gas, because whatever gas you have, if it contains hydrogen sulfide, it has to be removed. So we can treat those things.
So what is meant by glycol?
That is a glycol is used again as a chemical, but if you go through a process, chemical process, it has got a less value. If you make it a green MEG, methyl ethyl glycol, then it has got a more value, 4 times more value. Why I wanted to share with you, like if you do anything green, it gives you more value. For example, the digestrate which comes out of the digester here is organic fertilizer. Now everybody knows the organic fruits or organic vegetables which are available in the supermarket, we have to pay more. So the customer, our end user, is giving this organic fertilizer to the farmer, and they are growing organic crops which are getting higher value. It can also happen in Malaysia. Malaysia is again green, everywhere I go I find good trees, a lot of trees and plantation and farming. So if you produce organic fertilizer, it can be used for growing organic crops.
Thank you.